Now let us learn how to balance the redox reactions. See, we have been doing, or you people must be doing, the balancing of the normal chemical reactions from your standard 8th or 9th onwards, in which you are supposed to balance the number of the atoms of all the whatever the elements which are present on left hand side as well as from the on the right hand side. What is how these redox reactions are different from those normal balancing is that in this, in spite of balancing the number of the atoms which are present in the particular reaction, you are also supposed to balance the charges on both the sides. And due to which what happens is the reaction somehow becomes complex or complicated. Now, the balancing of the redox reactions is done by two methods. One is called oxidation number method, and the other is called half reaction method, which is also sometimes called ion exchange method. This kind of method can be used for both for ionic as well as for molecular reactions, whereas this method is mainly used for ionic reactions. Whenever we have ions in the reactions, we mainly use half reaction method. Whenever we have the molecular redox reaction given in the form of the molecular species, no ions involved, we mainly do it by oxidation number. But yes, the ionic reaction can also be balanced by the oxidation number also. Now let us learn how to balance the redox reactions by the half reaction method. There are certain rules which are to be followed while balancing the redox reactions by half reaction method. The first rule is divide the reaction into oxidation and reduction half. We will divide the reaction taking only those molecular species which are involved in the oxidation as well as in the reduction into two half reactions. Then balance atoms of all the other elements except hydrogen and oxygen. Leaving H and O, balance all the atoms of the rest of the elements by the simple method which you have been doing in your earlier cases. Then, how to balance then the hydrogen and oxygen? The third rule says balance oxygen by adding water molecules to the side which is deficient of water atoms, oxygen atoms. If suppose the right hand side is deficient of 2 oxygen atoms, we will put how many water molecules on the right hand side? 2 water molecules. If suppose left hand side is deficient of 3 oxygen atoms, we will put 3 water molecules on the left hand side. Now, the fourth rule is regarding the balancing of hydrogen. Hydrogen is to be balanced hydrogen by adding H plus ions in case of acidic medium on the side which is deficient of hydrogen atoms. And if the medium is basic, add OH minus ions, hydroxyl ions, to the same side which is in excess of hydrogen atoms followed by the addition of same number of water molecules on the other side. First, if the medium is acidic, simply add H plus ions to the side which is deficient of hydrogen atoms. And how many H plus ions you will add? It is, if the right hand side is deficient of 2 hydrogens, you will put 2 H plus ions. So according to the number of deficiency, the number of H plus ions are added if the medium is acidic. If the medium is basic, the side which is in excess of the hydrogen atoms, on the same side we add OH minus ions, and then the water molecule is added on the other side. If suppose right hand side is deficient, is in excess of 2 hydrogen atoms, we will put 2 OH minus ions on the right hand side and 2 water molecules on the left hand side. After balancing hydrogen, balance the charges of both the half reactions and add the two half reactions to obtain overall balanced redox reaction. Now let us see an example of an ionic reaction which is written in the form of the ions. It is basically a redox reaction and it is to be balanced by the half reaction method. In this, the permanganate ion is changing into Mn plus 2, so it is getting reduced, whereas the ferrous ions are getting changed to Fe plus 3, so they are getting oxidized. We will divide this reaction into two halves like this, the permanganate ion changing into Mn plus 2. Now how to balance this? The first is we have to balance our atoms of all the other elements except hydrogen and oxygen. So we have only manganese. Our left hand side is having only one manganese, right hand side is also having one manganese, so it is already balanced. Let us move to the oxygen. Here there are 4 oxygen atoms, whereas here on the right hand side there are no oxygen atoms. So how we can balance it? By putting 4 water molecules so that the oxygen atoms are balanced on both the sides. But by doing so, we have introduced 8, 4 2s are 8 hydrogen atoms on the left hand side, which are balanced by putting 8 H plus ions on the right hand side. Why H plus ions? Because the reaction which was given to us is already undergoing, is actually taking place in acidic medium, which is indicated by the presence of this H plus ion in the reaction. So hydrogen is to be balanced by the according to the medium, which is acidic, and it is done by putting up the H plus ion to the side which is deficient of the hydrogen atoms. This side was not having any hydrogen atoms, this side was having 8 hydrogen atoms, so it is balanced by putting up 8 H plus ions. So all the atoms are now balanced. How to balance now? The charges. See here, there are 8 plus and 1 minus, so net charges are 7 plus. Here there is only plus 2 charge. And how we can now balance the charges? Simply understand this. Electrons are, whenever they are added, they can only reduce the positive charge. So they will always be added to the side which is having a larger positive charge. So therefore, we can add only electron to this side. Now, how many electrons can be added so that this plus 7 becomes plus 2? Yes, it is 5 electrons. So by putting up 5 electrons, the charge also gets balanced. So this is how our first half is getting balanced. Let us move to the second half. The ferrous ion getting what? Oxidized to ferric ions. Here, we don't have the atoms of any other element except iron. And it is already Y balanced since there are one Fe on the left hand side, one Fe on the right hand side. Only thing left is the charges. Here we have +2, here we have +3. As I have told you, the charge can be balanced by putting electron and is always added to the side which is having what larger positive charge. So we can add only just one electron on the right hand side so that the net charge here is +2. Here it is also +2. Now both these halves are balanced. We will add now both these half reactions, and for this we have to ensure that the electrons gets cancelled on both the half reactions. And on what we find is in the first half where we have 5 electrons on the left hand side, in the second half we have only 1 electron on the right hand side, so it can be balanced by putting 5 electrons or multiplying the second equation by 5 so that it gets cancelled. Now let us add the two half. It will be MnO4 minus plus 5 Fe plus 2 because this Fe quantity is multiplied by 5, and 8H plus, it gives Mn plus 2, 5 ferric ions and 4 water. So this is how this equation gets completely balanced with respect to the number of atoms as well as charge. ठीक है जी, इसके बाद का जो भी होगा ना अगले रिएक्शन तक का वो सब हटा दीजिएगा. ठीक है जी. Now before adding we have to ensure that the electrons of both the half reactions gets cancelled. Same number of electrons are involved. So for this we will simply do the cross multiplication as we have been doing in the addition of the quadratic equations in mathematics. Since there are 5 electrons involved in the first half reaction and there is only 1 electron involved in the second half reaction, what we can do is we can simply multiply the second half by 5 so that this gets cancelled. Now simply add the two half. It will be MnO4 minus plus 8H plus from this first half. This 5 will, Fe will be multiplied by 5, so there will be 5 ferrous ions giving you what? Mn plus 2 plus 4 water plus 5 multiplied by this will give you 5 Fe plus 3. So this is what is your complete balanced equation which is there, and this is how we can balance the ionic reactions. Let us take one more example to understand the balancing of the redox reactions given in the form of ions or ionic reactions by half reaction method. The example is of dichromate ion, which when reacted with nitrite ion in acidic medium gets reduced to Cr plus 3 and oxidizes nitrite to nitrate ion. We will divide this reaction into two halves. One in which the dichromate ion is changing into chromium plus 3, and this is what is your reduction half is, whereas your NO2 minus is getting changed to NO3 where it is getting what? Oxidized. Now let us balance these two half reactions. The Cr2O7 2 minus changing into Cr plus 3. Now in this first half the chromium atoms are not balanced. They can be balanced by putting up a 2 here. Now the chromiums are balanced. We'll move next to the balancing of the oxygen. There are 7 oxygen atoms involved on the left hand side, which gets balanced by putting up 7 water molecules on the right hand side, because this will make the 7 oxygen atoms on the right hand side also. But by doing so, we have introduced 14 H plus or 14 hydrogen atoms on the right hand side, and they can be balanced by putting the same number of 14 H plus ions on the left hand side. So this is how all these atoms are balanced. Only thing left is the charge. Now let us see the net charge on this side. It is 14 plus and 2 minus makes it 12 plus. Whereas this side is only having 6 plus. As I told you, we can only add electron to the side where we have to reduce the positive charge, because by putting up a negative charge, the positive charge gets reduced. Here there are 12 plus, here it is 6 plus, so we can put 6 electrons here on the left hand side. This will make this charge to turn to what? 6 positive, and this is how both these this left hand side and right hand side gets balanced. Now let us see the other half. The other half is of nitrite ion changing into nitrate ion. In this, the atoms of the other elements are only of nitrogen, which are already balanced. One nitrogen, one nitrogen. We will move to the oxygen. There are 2 oxygen atoms here. Here there are 3. How to balance it? By putting up a water molecule to the side which is deficient of oxygen atom. So we have added 1 water molecule here. Now oxygen are 3 here, 3 here. They get balanced, but this side acquires, left hand side acquires 2 hydrogen atoms. Since the medium is acidic, how hydrogen is balanced? By putting up 2 H plus ions on the right hand side. So this is how the atoms gets balanced. Let us balance the charges. This side only 1, so it's minus 1. This side minus 1 and plus 2 makes it plus 1. So how to balance the charges? I told you we can add only electron to the side which is positive, so that it becomes, we can reduce the positive charge. It is already minus 1, plus 1 is the net charge here. We'll put 2 electrons here so that it gets changed to minus 1. So charges also gets balanced. Now what we will do is, we'll add these 2 half reactions. How we can add these 2 half reactions? By simply adding these 2. But before this, we have to ensure that the electrons on both the half reactions must be same in number, so that they get cancelled. Here there are 6 electrons, here there are 2 electrons. How we can make them get cancelled? By simply multiplying the second half reaction by 3. So that this becomes 6, this becomes 6. What we can do is, it is now Cr2O7 2 minus 14H plus. Now this side, whole side gets multiplied by 3, so it will be 3 nitrite ions plus 3 water molecules changing into 2 Cr plus 3 plus 7 water plus 3 NO 3 minus ions and plus 6 H plus. Now you can see here 14 H plus ions are consumed, 6 H plus ions are produced, so net will be how much? 8. Similarly, 3 water molecules are consumed, 7 are produced, so net will be 4. 4 are produced. So we can rewrite this equation as Cr2O7 2 minus plus 8 H plus ions plus 3 nitrite ion. This gets cancelled, as you have been knowing here, the net 4 water molecules come on the right hand side, followed by 2 Cr plus 3 plus 3 nitrate ion plus 4 water molecules. So this is your net balanced equation at the end. So this is how we can balance the redox reactions given in the form of the ions by half reaction method. Let us take one more example of an ionic redox reaction, which is to be balanced by the half reaction method. But this time we will take the example which is taking place in basic medium. Let us take an example of the permanganate ion taken in basic medium. It's a very strong oxidizing agent, and it oxidizes iodide ion to iodate ion. Itself gets reduced to MnO2. So your permanganate ion is changing into MnO2, so it is getting reduced. I minus is getting what? Oxidized to iodate ion, so it is undergoing oxidation. We can write the 2/2 as MnO4 minus, changing into MnO2. This is the first half. Let us first balance this. Remember, as it is indicated, the medium now is basic. The manganese are already balanced. How we can balance oxygen? There are 4 oxygen atoms on the left hand side, 2 on the right hand side. How we can balance the oxygen atoms? By putting just simply the 2 water molecules on the right hand side. So oxygen gets balanced. Now, we know that we have to balance now hydrogen. Since the medium is not acidic, it is basic. How we can balance hydrogen atoms? By putting, how many hydrogen are there in, or more in this case of on the right hand side? 4 hydrogen atoms. So we will put the same number of OH minus ions. There are, since 4 hydrogen atoms on the right hand side, 0 on the left hand side, we'll put 4 OH ions on the right hand side, followed by 4 water molecules on the left hand side. Because this H and OH will make water, and same number of water molecules are added on the left hand side, so it gets balanced. So by doing so, all atoms are balanced now, except the charges. Now, the things are balanced. Here we have on the left hand side only -1 charge, whereas on the right hand side we have 4 minus charges. So how we can do it? We know that we can increase the negative charge, we can decrease, and by adding electron, positive charge gets lowered or decreased. So we have to now increase the negative charge by how many? To -4. So we simply add 3 electrons to the left hand side. So now this half gets balanced. Let us move to the second half. The iodide ion is getting oxidized to iodate ion, IO3 minus. Iodine already balanced. Move to the oxygen. There are 3 oxygen here, 0 on this side, so 3 water molecules are added, so that oxygen gets balanced. Now, this side acquires 6 hydrogen atoms. So how they are balanced? By putting 6 OH minus ions followed by 6 water molecules on the other side. This is how even all the atoms gets balanced, leaving behind only the charges. Move to the charges. 6 negative, 1 minus, so this side is 7 minus, whereas this side is only 1 minus. How we can balance it? By putting up 6 electrons on this side. 6 electrons. So it is 6 and 1, 7, 6 and 1, 7. This makes the charge, both the halves getting balanced. Now we have to add the 2 half reactions. How we can add? There are 3 electrons on this side, 6 on this side. So what we can do is we can simply multiply this first half by 2, so that the electrons gets balanced. Please also remember we have to balance the water molecules and hydroxyl ions. Here, when we will multiplying this by 2, it will become 8. And 3 are added here, so the total will be 11. So first write down the reaction first. If you are smart enough, you can do these cancellations, simple calculations here only, or it is better always to write down by putting up or by adding both these half reactions together. 8 water here and 3 here, and when multiply by this, it will become 2 permanganate ion. So 2 permanganate ion, 8 and 3, it will make 11 water molecules, plus iodide ion plus 6 OH minus ions will turn to 2 MnO2, because we are multiplying this side by 2. 2 2s are 4, 4 water here and 6 water here will make it what? This will make 4, 4 and 6 plus 10 water molecules plus iodate ion plus 2 4s are 8 OH minus ions. Now, there are 11 water here getting consumed, 10 are formed, so this gets cancelled, leaving behind just only 1 water molecule. Whereas 6 OH minus as consumed, 8 are produced, this gets completely cancelled, leaving behind only what? 2 OH minus on the right hand side, sorry. So the net equation becomes the twice of permanganate ion, 2 permanganate ions reacting with iodide ion and 1 water molecule, giving us 2 MnO2 plus iodate ion plus 2 OH minus ion. So this is your net equation, which is already balanced both with respect to the atoms as well as charge.